Alright, so now we're finally done with those pesky proofs and we're getting into some more algebra type stuff. We're going to talk about radians, which we will now use pretty much to replace degrees as our angle measurements. So you can pause it here and read these if you want. We'll go more over in class. Alright, here's the definition of a radian angle measure. So radian angle measure, see if you have a central angle theta in a circle with radius r intercepts an arc of length s, then the measure of theta in radians is arc length over radius. So what it really is it's this length here on the picture over that length. So it's a ratio of essentially what looks like a pizza slice. And the key thing here is r and s have the same units. A radian shouldn't have units. Like it shouldn't be 8 pi radian meters per second or something like that. It should just be 8 pi. It's typically a unitless measure. So knowing our new definition, let's go through and let's find the radians for these. So we said in radians theta equals arc length, which is s over r. So here you would have 8 over 4. Now these are both centimeters, which is good because that means the units would cancel, like that stoichiometry or whatever it's called that you learn in chemistry that most you hate. And so you end up with 2 rad or 2 radians here. And this next one you have 9 inches over 1 foot. One thing you'll notice, units won't cancel, so you have to change it to make it so they would. See, that would give us 9 inches over 12 inches. I wouldn't convert the 9 inches to feet because then you get a fraction, or you'll end up with a fraction or a decimal, and that just makes this whole thing a little more complicated. And in any case, now what you'll notice, inches and inches cancel. 9 and 12 both have a common factor of 3, so you end up with 3/4 of a radian here. And like I said, a lot of people get all tripped up because they don't really know what a radian is. And it's just a unit. I mean, that's all, just like a degree. The only difference is a degree you're used to because you've seen it forever. Radians just takes a little bit of time because they're new. So how do you convert from a circle to all of this? We'll go over this more in class. The key thing here is you're just using this relation or this ratio to multiply back and forth. And if you think about the chemistry again, the pi and the 180, you can tell which one goes on top and which one goes on the bottom based on what unit you're trying to cancel out, what unit you're trying to get as an answer. So what I mean by that, so we said pi over 180 is our ratio. If I want to go from radians to degrees, that means, that when I multiply this by my ratio, I want the radian unit to cancel, which means that the radians on top here has to be on the bottom here. So that's pi. I want the degree answer to be my actual answer because I'm converting 2 degrees, so the degrees goes on top. So here I cancel out a pi, radians cancel, I end up with 3 times 180, which comes out to be, should be 540 degrees. Alright, this guy here, once again we're multiplying it by 180 over pi radians. So here, radians cancel, pi's cancel. You have 5 over 6 times 180. 6 goes into 180 30 times. So you get 150. So not so bad. The hard part is just determining which one of these is on the top and which one's on the bottom. So now we're going the other way. So now since I want my degrees to cancel, want my degrees on the bottom. I want radians on top, because I want my final answer to be a radian. So we have 120 pi over 180. What are some common factors there? Hopefully we've picked 60 as a common factor, because 60 goes into 120 twice, goes into 180 3 times, so you end up with 2 pi over 3. And then we will leave these answers in what's called terms of pi, meaning the pi just stays in the answer, you don't multiply it in, because that's a whole lot nicer than having like some crazy decimal. Alright, so we try the second one now. Like I said, if you wanted to pause the video, give it a shot, and then go for it. And you can check your answer then when we're done. So 270 pi, that's terrible again. 180. Here, 90 goes into both of these. 90 goes in there twice, 90 goes in there 3 times. So you get 3 pi over 2 radians. That's it. Hope this makes sense. If you have questions, ask me in class tomorrow.